Hi, everybody. In today's lesson, we're going to talk about theoretical and experimental probability and the differences between them. This is Mrs. Pagan, so let's go ahead and get started. All right, so the probability of an event happening is, remember that it's a number between 0 or 0% and 1, which is 100%. That indicates the likelihood of an event happening, okay? So we're going to run an experiment. I'm going to show you how the experiment is different depending on what we are talking about. So theoretical probability is what should happen. This is the one that your brain thinks of right away. Like, oh, it should be this number. This should be the answer. So kind of like what we were doing yesterday. So let's look at this. These cards. We have a card is drawn at random from the set of cards shown below. Find the theoretical probability of following an event. So we're having like a party, family party here. And so now we're going to answer these questions. So it says, hey, what's the probability of me getting the letter T? Well, there's only one T here, so that's 1 out of 1, 2, 3, 4, 5 cards. So probability of that happening is 1 out of 5. What's the probability of me getting a vowel? Remember that the vowels are A, E, I, O, U. So we have an A, and therefore that is 1 out of 5 cards as well. Then the question changes, well, what's the probability of me getting a T or a vowel? Well, A is a vowel and T is a T. So that's 2 out of 5 cards. And then it says we want a consonant. So consonant is everything that's not a vowel. So P is a consonant, R, T, Y. So we have 4 out of the 5 cards. And then the last one is not a vowel. So what are the chances of me not getting a vowel? Well, P, A, R, T, Y. These are not vowels. A is, so we are not going to include that. So it's 4 out of 5 again. Oh, sorry. Hold on. My screen is going blank on me. There we go. So that's 4 out of 5. And then it says, what's the chances of me not getting a Y or not getting an R? So P is not a Y or an R. A is not a Y or an R. And T is not a Y or an R. So that's going to be 3 out of the 5. So basically saying, hey, don't pick an R and a Y. Excuse me. All right, so that is theoretical probability, what should happen given the number of cards that we have, okay? So now let's talk about experimental probability. So experimental probability is what happens. So what does happen when we run, so what happens when we run the experiment? And basically this changes every time we run the experiment. So what we thought should happen might not necessarily happen depending on our experiment, okay? So Janessa and Ricky perform an experiment to calculate the probability of choosing certain cards from the cards shown above. They randomly choose a card 14 times. So that's how many times they pick the cards. And below is a tally of how many times they chose each card. Calculate the following experiment probability. So I'm going to make sure I have 14 tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my total is 14. Okay? Now these tick marks mean that I pulled a P 3 times, an A once, R 4 times, T twice, and Y 4 times. So when it says, what is the probability of me getting a T? Well, I'm looking at it and I have 2 T's, so that's 2 out of 14, which reduces to 1 out of 7. Well, that's not what I said was going to happen. I said that every 1 out of 5 was going to be a T, but in the experiment, it ended up being every 1 out of 7. So experimental and theoretical probability might not be equal in value depending on what my experiment said it was, okay? So for the vowels, well, I only have one vowel, so that's 1 out of 14. That's not what I said above. I said it's going to be 1 out of 5. So you can tell the difference between the two answers already. Now, what's the chance of me getting a T or a vowel? So that's an A or a T, so that's 1, 2, 3. So that's 3 out of 14, and that doesn't reduce. What's the probability of me getting a consonant? So that's everything but A. So that if I just take that one out, that's 13 out of 14. And what's the probability of me not getting a vowel again? These are the same questions ultimately. It's 13 out of 14 again. And what's the probability that I won't get a Y or I won't get an R? So I have to count the other ones. 1, 2, 3, 4, 5, 6. So that's 6 out of 14, which reduces to 3 out of 7. Okay, so if you compare what happened in the experiment to what we thought it should happen, you'll notice that none of them are equal in value. Okay, they could have been, but they're not. All right, so let's go ahead and look at the second experiment. So experiment number 2 is talking about a single 6-sided die is being rolled. So the question is, once again, what are all the possible outcomes? Well, one of the outcomes is I can land on 1, I can land on 2, 3, 4, 5, or 6. So those are all the possible outcomes. And then the question is, what's the theoretical probability that each number is rolled? Well, in theory, I should have 1 6 for each of the numbers, right? This is what comes to our mind when I think of, hey, what's the chance of me landing on 1? 1 out of the 6 total numbers. What's the probability that 2 is not rolled? Well, I only have, if I get rid of the 2, I have 5 other numbers, so 5 out of 6. Now we're running the experiment. So it says, suppose you roll a die 10 times. So that is my total. And it lands on 2 4 times. What's the experimental probability that 2 is rolled? Well, I have 4 of them out of the 10 that I rolled. So that is 2/5. This would be my experimental probability, because this number came from the experiment I ran, which is 40%. Okay, so sometimes the experiment, I might just end up getting a bunch of 2s, and the experimental probability just skyrockets. Okay, now the theoretical probability of rolling a 2 was 1 out of 6. This was in theory. Okay, and in theory, this is 16.6%. Does this match the experimental probability? I mean, it's really obvious, right, that they don't match. One is 40, one is 16. So our answer to that question is no, it does not. And it says explain why or why not. Well, the reason is the theoretical probability does not match the experimental probability. Oh, sorry, we got interrupted. So experimental probability, because we rolled a 2 4 times out of 10, increasing our chances. Right? Like, we were expecting it not to happen that often, but it did. It's an experiment, okay? So it did increase our chances. Now, it says, based on throwing that die 10 times and getting 2 4 times, what's the experimental probability that 2 is not rolled? Well, if I got 2 4 times, 1, 2, 3, 4, that means I got not 2 the rest of the time. 1, 2, 3, 4, 5, 6. Because together these are supposed to be 10, right? So out of how many times did I not roll a 2? Well, the probability of me not rolling a 2, well, I wanted that line to be squiggly, sorry. Not 2 is 6 out of the 10 times, which reduces to 3 out of 5. Oops. Or 60%. So 60% of the time I did not get a 2. All right. Well, that's all I have for you for today. I hope that was helpful. Looking forward to seeing you in class. Have a great day. Bye.